We just haven't really put it all together yet. Sometimes textbooks will tend to show this first before they do the unit circle. Okay, so what I want you to do on here is we're going to draw a diagram. I want you to just draw a diagram in here. Just draw like an axis, kind of like this. And what we're going to do is what the trig functions can be defined as beyond the unit circle. You could just say, okay, I have a point. So just put a dot somewhere in quadrant 1. Label that P and then XY. Okay, like that. Okay, then what we're going to do is I'm going to have you just connect the origin with a ray like that. And what we're going to do is we're going to make this into a triangle. So you've got an angle theta there. And then if you go straight down to the x-axis, then what you have is you have a triangle. All right. So what you would have here is this part of the triangle would be what? How far over are you? X. That's what I'm trying to get at. Okay. What would be the height of the triangle? Y. Good. Okay. And then the radius is R. Okay. So this is not for a unit circle. This is if R is anything. Okay. So what happens is the trig definitions are based on X, Y, and R. So it goes like this basically. And I want to kind of talk through this and hopefully this will make sense to you. Remember the sine was opposite over hypotenuse, right? So if you look at this, what is opposite and what's hypotenuse? Y over R. Okay, so the sine is Y over R. The cosine is adjacent over hypotenuse. So adjacent's X, R is the hypotenuse, and so forth. Okay, what we learned in the unit circle was the cosine was just X, but that was because the radius is 1. So that's why you get X. We learned that the sine was the Y value because R is 1. Okay, so it's all the same. We also learned tangents y over x. You learned that that was opposite over adjacent, so that matches up. Does that make sense to you? Okay, because you want to make the connection that this is opposite over hypotenuse, this is adjacent over hypotenuse, and so forth. So those are the technical definitions of the 6 trig functions. We learned what the reciprocals are already. Okay, any questions about that? Okay, all right. So a couple of observations on here then. This is stuff that we've already learned, but the sine, what is the reciprocal of the sine? Cosecant. So you want to get that down. Reciprocal of cosine, what's that? Secant. Reciprocal of tangent is cotangent. Okay? The value of r must always be positive. Okay, you're always going to have a positive radius. And then remember, if from the Pythagorean theorem, if you look at the diagram I had you draw, you would have x squared plus y squared is equal to r squared. Okay, that's just the Pythagorean theorem. A squared plus b squared equals c squared. So what you would have is you would have the relationship r squared is x squared plus y squared. Again, that comes from the Pythagorean theorem. Okay, so that's the idea. All right, so those are kind of the formal definitions of your 6 trig functions in terms of x, y, and r. Okay, so the first thing that I want to do on here, the purpose of this activity is to get you to understand x, y, and r and how they give a trig function. So what we're going to do is I give you a point and we're going to find the 6 trig functions. Okay, so first of all, I've given you x is 9. I've given you y is 12, and you have to know x, y, and r to find all 6 of the trig functions. Okay, how do you find r? You do r squared equals x squared plus y squared. Okay, so we're going to crunch that out. Sometimes you'll get whole numbers, sometimes you'll get radicals. So that's r squared equals 9 squared plus 12 squared. So that would give r squared equals 81 plus 144. So that would be r squared is equal to, what is that, 225? Yeah, okay. Then you do square root of both sides. So you end up getting r is 15. So that's called a Pythagorean triple because all of them are whole numbers, okay? So now what we do is we just go to our definition. So it's real simple. The sine is y over r. So that would be 12 over 15. Then you want to reduce your fraction. So you can reduce that by 3 to get 4/5. Okay, so that's what the sine is that's 4/5. Okay, all right. While you're at it, you might as well get the cosecant. The cosecant is just the reciprocal of the sine, so that's going to give 5/4. Okay. The cosine is x over r, so you would have 9 over 15. You can reduce that fraction by a factor of 3 to get 3/5. And then the secant is the reciprocal of the cosine, so that's going to be 5/3. Okay, like that. All right. And then finally, the tangent is y over x. I'm going to erase this stuff here from the Pythagorean Theorem. So if you did y over x, it looks like y is 12, x is 9. You can reduce that by 3 to get 4/3. And then the cotangent's the reciprocal of the tangent, so that's going to be 3/4 like that. Okay? So that's basically how you would do that then. All right? Now what would happen on this is you want to write these just as fractions instead of decimals. Just write these things always as reduced fractions. Okay? All right, everybody with me there? That's a real fundamental thing that you do to make sure that you know the definitions. Okay? All right, I'm going to do one more of these because it's the same idea. So on number 3, x is going to be -9, y is going to be 5, and you got to crunch out what r is. So r squared is going to be x squared plus y squared. So we're just doing the Pythagorean theorem to find the hypotenuse. So that's r squared equals 81 plus 25. So that's r squared equals 106. And then you square root both sides. So you would get r is equal to the square root of 106 like that. Now that doesn't reduce, but you got to be aware that sometimes radicals reduce like we've learned, so you have to do that. Okay, and then r is always positive. Okay, there's no such thing as a negative radius, at least until you get to polar coordinates, that is. Okay, so what we do from here is the sine is y over r, so that would be 5 over root 106. And I'm not going to do any of the rationalizing yet. I usually just kind of save that till the end. So the cosecant, you might as well do that now. It's just the reciprocal of the sine. So that's square root of 106 over 5. That takes care of that. The cosine is x over r. So that would be -9 over square root of 106. Okay, the secant's the reciprocal of the cosine. So that would be negative root 106 over 9 is just a negative, so put the negative in the numerator is kind of standard. The tangent's y over x, so that would be 5 over -9. Best way to write that's -5/9. And then the cotangent's going to be the reciprocal of that, so that's -5/9 like that. Okay? Now remember, rationalizing a denominator, remember that means if you get an answer and you have a radical on the bottom, you want to get rid of it, right? So how do you make that square root of 106 go away? Times by what that radical is. Okay, you'll do this over and over again in this part of the class. So, and you can even do this in your head. I don't care if you just write the answer. So you do this. So the answer to that is what? 5 root 106 over 106. Good. That makes the radical go away. Okay. Same thing with this. And again, you'll do this so much you can just write the answer in your head if you want to. So that's -9 root 106 over 106 like that. Okay, so those would be your values of your 6 trig functions. Okay, so it's just a matter of knowing what x, y, r is, what they mean, and what the definitions of the 6 trig functions are. Okay, everybody with me there? Okay, okay, all right. Okay, so let's just go ahead and do this one yourself. This one's, I think, no radicals in it. I'll put the definitions up here because you're in the process of learning these. Sine's y over r, cosecant's r over y, cosine's x over r, secant r over x, tangent's y over x, cotangent's x over y. Let's go ahead and take a minute and do those, and then we're going to talk about special triangles. This problem I have put on the calculator part of a test for many years, and the non-calculator part, and about half of my students don't figure out what r is correctly without a calculator, so I want to talk about that a little bit. Okay, if you put this in, you would have r squared is -5 squared plus 12 squared, so that's r squared equals 25 plus 144. So that's r squared equals 169. And I see this all the time from students in this class, just leaving it that way, okay? What if you don't have a calculator? What do? You just multiply backwards until you find it, hopefully, okay? So what will happen is the last digit is 9, therefore the last digit has to be 3, so the only thing that makes any sense is 13, okay? Use a little bit of reasoning on that. Don't get totally reliant on your calculator, all right? Because I see that all the time. All right, now from here it's real straightforward. So the sine is just going to be 12 over 13. Cosine is going to be negative 5 over 13. Tangent is 12 over negative 5, but just write the numerator as negative. Then do your reciprocals, then you got it. Okay, so that's not, this kind of problem is not a very big deal for students. As long as you can work with rationalizing and figure out r, you shouldn't have any trouble, as long as you know the definitions. Okay? All right, now our textbook does the unit circle before triangles, which is kind of weird because the unit circle comes from triangles, so I'm going to go ahead and show that to you. So if you learn the unit circle, you can actually kind of bypass the special triangles, but I want to go ahead and show you kind of how this relates to the unit circle. So you have what we call a 30-60 right triangle that you want to memorize, and these sides are related by the Pythagorean Theorem. So if you did this, these would be the legs. Let's just write down the Pythagorean Theorem. That would be 1 squared plus square root of 3 squared is equal to 2 squared. I just want to verify that that works. So that would be 1 there. You square the radical, it comes off. 2 squared is 4, so see, that does satisfy the Pythagorean Theorem. Now what I'm going to show you on this, I'm not going to go through every detail of this, but I want to show you why we know that triangle, why the sides can be reduced to 1, 2, root 3. Okay? So what you do is you start with an equilateral triangle, and I want you to write down a couple things on this. If you have an equilateral triangle, first of all, what do you think all the angles are if all the sides are equal? What's logical?
The same.
60. Yeah, they're going to be the same. That's a mathematical theorem. I'm not going to prove it, but that's usually stuff you prove in geometry classes, so they have to be the same. And then what happens is if you go straight down with what you call an altitude of that triangle, this is also a common geometric theorem. What happens is, what do you think that little piece would be? Instead of 1, what do you think? It's a half, okay? That's a geometric theorem that we know for a fact, too. So that's a half like this. And this angle gets cut in half, so that 60 gets cut in half to a 30. So what you end up having is you end up having this. You have a 30-60 right triangle, with this being a half and that being 1. Now what will happen is if, and I'm not going to show this step, I'm just not going to take the time to do it, if you found the missing side by Pythagorean theorem, you would get square root of 3 over 2. So on the unit circle that you're going to do on your quiz today, root 3 over 2 is all over the place, right? So is a half. That's where all those numbers come from. So basically what happens then is if you take every side and multiply every side of this by 2, you get this triangle. So you get root 3, 1, and 2. So this thing changes into 2, root 3, and 1, with that being 30 and that being 60. That's where it comes from. Does that make sense to you? Okay. All right, so it is good to know where this stuff comes from so that you can develop it if you need to. All right. Okay, let me do the 45-45 right triangle. Its derivation is actually easier even. So if you have a 45-45 right triangle, the sides can be reduced to 1, 1 square root of 2. Okay, here's how I'm going to do this. On this square, I want you to just call every side 1. Okay, like that. And what I'm going to do on this is, you know that every angle is 90. So what happens if you have a square and you have a diagonal? It just divides it up into 2 45-45 right triangles. So you have 1, 1 there. If you did the Pythagorean theorem, you would get square root of 2. So that's where that comes from. I'm not going to do the Pythagorean theorem, just give you the idea of where that comes from. Okay, we've known that for over 2,000 years. Okay, so that's the idea. All right, so let's show you kind of what we're going to do with this. Now, when you're doing your homework on this, you could do this with the unit circle. I don't really care. What I'm going to do on this, though, mostly is we're just going to look at triangles on this. Okay, then I'll show you how this relates to the unit circle anyway. So if you have a 30-degree angle, then that would cause you to have a 30-60 right triangle, okay? And one thing you want to remember is the sides go 1, 2, square root of 3. 1, 2, 3. It's as easy as 1, 2, 3, but the 3 is a square root. Okay, and what you want to think of is this is the smallest number. This is 1.7. And then this is the biggest, like this, okay? Because a lot of times students get this totally backwards. Where's the logical place to put the 1? With the smallest angle, right? 30 is the smallest angle, so the 1 goes there. Where's the logical place to put the biggest? Well, that's always the hypotenuse, right? So you want to understand how to do that. The 1 matches the 30, the 60 and root 3 go together, and 90 and 2 go together. Is that sensible? Okay. Now here's what you have. The definition that you learned was that the cosecant is hypotenuse over opposite. So that means if you're looking at 30 degrees, then you're looking at hypotenuse and opposite. So that would be 2 over 1. Therefore, the answer to that problem is 2. Okay, that's how that goes. Now, you can do exactly the unit circle the way I taught you. It's less work, so I don't care. But I do like you to at least see this connection between the triangles and the unit circle. Okay, all right, pi over 4 is 45 degrees. So what we're really doing on this is we're doing the sine of 45 degrees. So if you looked at your 45, 45 right triangle, it's going to go like this. This is 45, 45. The sides on that go 1, 1, square root of 2. Square root of 2 is like 1.4, so that's the biggest side, all right? And then what you have is we learned the sine is opposite over hypotenuse. That means if you look at 45, opposite is 1, hypotenuse is root 2, so you get 1 over root 2, all right? You rationalize the denominator on that, you're going to get square root of 2 over 2, all right? Now what we learned on the unit circle is this, and the unit circle is certainly faster because all you do on the unit circle is you find 45 and you look at the y value to find a sine. Boom, boom. But that's where it comes from. I want you to see the connection more than anything else. Everybody okay with that? Okay. All right. So let's do these next two here. And again, with this one, we're just going to look at the triangle. Okay. So we got 30, 60. Okay. The sides go like this. 1 matches 30. 2 matches 90. Root 3 matches the 60. Okay, so the secant we learned was, this one was hypotenuse over adjacent. So if you're looking at 60 degrees, then you'll be looking at hypotenuse 2, and adjacent would be 1. Okay, so you would end up on this one having 2 over 1, so that's equal to 2. If you went to the unit circle, the way I taught you, then what you would do is this. On a unit circle, the easiest way to do the secant of 60 on a unit circle is look at the cosine. The cosine's a half, right? What's the secant? It's upside down, it's the reciprocal. So that certainly is the fastest way to do that. Everybody with me okay? All right. Okay, and then this last one, 45, would go like this. You have a 45, 45 right triangle. So the sides go 1, 1, square root of 2. And then you would have the tangent of 45 is opposite over adjacent. So that would be 1 over 1, so that's equal to 1. If you look at the unit circle, what do you do when you look at the tangent of 45 on a unit circle? You do y over x, right? So this divided by this is 1, right? Okay, so that's the connection that I'm trying to show. Okay? Okay, let's move to what we're talking about, quadrantal angles. I want to run through this next. Okay, so quadrantal angles are these angles. They're basically angles that are on quadrants. We talked about this a little bit earlier. So your quadrantal angles are like 0 degrees, 90 degrees, 180 degrees, 270, and of course on, because you can go around the circle as many times as you want to. You can also have negative quadrantal angles, okay? So the key thing on this is you want to know from your unit circle that this point is 1, 0, this is 0, 1, that's negative 1, 0, that's 0, negative 1, like that. Because one of the things you want to be able to do is figure out trig functions real quickly without having to rely on a calculator all the time, okay? So we're going to run through this, and then we'll do the quiz, and then we'll do the break here. Okay, so if you're at 0 degrees, Okay, that means that you're on the x-axis, so you have the point 1, 0 on the circle. So you would have x is 1, y is 0, r would be 1. Okay, everything from here is all the same stuff. So you can do the sine is y over r, or you can just do y. So that would end up being 0 over 1, so that's 0. So that means the sine of 0 is 0. Okay, the cosine is x over r. So x is 1, r is 1. So the cosine of 0 degrees, or 0 radians, is 1. Okay, the tangent is y over x. Okay, so that's going to be 0 over 1. So that is 0. And then you can do your reciprocals. Okay, all right, what would be the cosecant?
Undefined.
Undefined, good. Okay, because if you do the reciprocal of 0 over 1, you get a 0 denominator, which makes it undefined. Okay, the reciprocal of the secant would be 1 over 1, so that's still 1. Then the cotangent would be the reciprocal of the tangent, so that's 1 over 0. So again, that's undefined. Okay, and you want to be able to do this kind of quickly in your head without having to write stuff down. Yes?
This might be a silly question, but how do you know that a of 0, well, a being 0, you're asking for x, y?
Okay, because anytime what we're doing is we're finding the value of a trig function. And anytime you're finding the value of a trig function, it boils down to knowing the ratio of x, y, and r. Because of the definitions. Okay, the sine's y over r, so you have to have y and r. Cosine's x over r, so you have to have x and r. So whenever you're asked to find a trig function, your focus should be find x, y, and r.
So when I get 0, I'm thinking that's x is 0. Because you just gave 0, so that was
yeah, and you can look at the unit circle. So like we're at 0 radians, so that's the point.
0 radians.
Yeah, okay, yeah, okay. All right, now I want to show you a pattern. We're going to crunch out each of these angles, and I'll show you a pattern here. Okay, now this one is 90 degrees. Okay, so if you do this, on the unit circle, you would have the point 0, 1. Okay, so that means x is 0, y is 1, r is 1 like this, okay? Now I'm not going to write the definitions, I'm just going to do these in my head. The sine is y over r, so that's 1 over 1, so that's equal to 1. Okay, the cosine is x over r, so that's 0 over 1, so that's equal to 0. Okay, the tangent's y over x, so that's 1 over 0, so what do you say? Undefined. Okay, so we have that, all right? Then you can do the reciprocals. The cosecant would just be the reciprocal of the sine, so that's still 1. The secant is the reciprocal of the cosine, so that would be undefined. And then the cotangent would be the reciprocal of the tangent, that's 0 over 1, so that's equal to 0. Now there's a pattern to this stuff when you do this. If you notice the answers we got, there were 2 undefineds at 0, there were 2 undefineds at 90, right? There were 2 zeros, and there were 2 1s. Okay, that's the way it works out. You always have 2 of each. Now they can become negative as we go to the next quadrants. Okay? All right, let's put this one together. This one is pi. Pi is 180 degrees. Okay, so on your unit circle, you would have the point -1, 0. So x is -1, y is 0, r is 1. Okay, when we put it together, sine is y over r. So that would be 0 over 1 is 0. Cosine's x over r, so that's -1, so you'll start getting into negative answers now. Tangent is y over x, so that's 0 over -1, so that's 0. Cosecant is reciprocal of sine, so that would be undefined. Remember, you're going to have 2 undefineds here. Then the reciprocal of the cosine would also be -1, and then the reciprocal of the tangent would be the cotangent, so there's your second undefined. So see how you get 2 zeros, 2 undefineds, and 2 1s or -1s. That's nice to know patterns, okay? Okay, then the last one, we've got 3 pi over 2 is 270. So when you're at 270 degrees, you're at the point 0, -1. So in this, x is 0, y is -1, r is 1. Then you do the same ratio. So the sine would be y over r, so that's -1. Cosine would be x over r, so that's 0 over -1. Tangent's y over x, So that's negative 1 over 0. So there's one of your undefineds. And cosecant is reciprocal of sine, so that would be negative 1. There's your two negative 1s. Secant is reciprocal of cosine, so that's another undefined. And then finally, the cotangent is 0 over negative 1, so that's 0 like that. Okay, so that's the idea. All right, and a couple of things on this. A trig function, what is it that makes the trig function undefined? Well, it just means you have a 0 denominator. So anytime the denominator is equal to 0, that's when the trig function's undefined. Okay, now let me ask this question. Do you think the sine of 0 radians would be the same as the sine of 2 pi or different? Same. How come they're the same? It's the same angle, exactly. We call that coterminal. So yeah, they're going to be the same, and it just means that you have coterminal angles. So you're going to end up with the same ratio of y over r. That's how that goes, okay? All right, everybody okay? Comfortable with this so far? Okay, next thing we're going to look at a little bit is what will happen is the trig functions are positive and negative depending on what the quadrant is. So I'm going to take you through this thought process. This is like a super important part of trig, is to be able to reason this out. You don't want to memorize this. You want to be able to reason it out on the spot when it shows up. Okay, quickly, let's just write down the definitions of these things. So the sine's y over r, cosine's x over r, tangent's y over x, cosecants r over y, secants r over x, cotangent's x over y. Okay, now that's incredibly important to remember that, because really all trig comes from those definitions. We talked about r is always positive, and that's because it's a radius. And a radius is a distance, and distance is always positive. That's the reason that we have that then. Okay, so this is kind of the basic stuff that we want to go through. So I'm going to have you just draw an XY axis here. And what we're going to do is let's just label the quadrants. Quadrants go counterclockwise, so that's quadrant 1, 2, 3, and 4. And we use Roman numerals around like that, okay? So if you're in quadrant 1, well, here's what happens. X is positive, Y is positive, R is positive. And since you know that, then you can figure out what all the trig functions are, if they're positive or negative. So the value of X is positive in quadrants 1 and quadrants 4, okay? If you go to quadrant 2, then X is negative, Y is positive, and then R is positive. You go to quadrant 3, X is negative, Y is negative, and R is always positive, of course. You go to quadrant 4, X is positive, Y is negative, and then R is positive like that, okay? So what you get on this then is you can use that to reason this stuff out. So X is going to be positive this way, okay? Just in your head, just categorize. X is positive that way, X is negative that way, all right? So what you'd have is X is positive in quadrants 1 and 4. X is going to be negative in quadrants 2 and 3. Don't memorize that, understand it, and figure it out as you go. Okay, Y goes like this. Y is positive when you're up there, okay, and then you're negative when you're down there. So the value of Y is going to be positive in quadrants 1 and 2, and it's going to be negative in quadrants 3 and 4. Okay, so if you know that information, which you should from graphing, then you can figure all this stuff out easily. Okay, everybody with me in what I'm talking about here? Okay, all right. So that's just how points work. Now what we're going to do is you have to do this in trig sometimes. You have to reason out what quadrant you're in based on a series of conditions. So what I'm going to do is I'm going to show you this. Before I go to this next page, I want to show you this. So what we're going to do is just the sine. I'm just going to have you put sine, cosine, and tangent. And if we can figure those three out, then you easily reason out the rest. Over here, sine, cosine, and tangent, and so forth. So I'm going to show you how to reason this out in your head without having to write anything down. And then there's a couple of things I can teach you that you can memorize if you want to. Okay, so here's the way I look at this, is like this. Okay, the sine is y over r. Okay, where is y positive? There, so that's where the sine is positive. Where is y negative? Down there, so that's where the sine is negative. So you want to reason that out in your head. So let's just do this then. Okay, so the sine's positive up here. Okay, so you'd have a positive sign there, a positive sign there, negative and negative like that. It's because it's y over r. That's all you got to know. Okay, the cosine is x over r. So where is x positive? That way, right? Where is x negative? That way. Good. Okay, awesome. Okay, so what we'd end up having then is the cosine is going to be positive here and there, and then negative here and there like that. Okay, that's how I'm figuring that out. Okay, now the tangent's y over x. Okay, so if we do this, okay, if you did y over x, positive over positive is going to give you a positive in that quadrant. If you go to this quadrant, you would have positive over negative, so that would be negative. And then if you go to quadrant 3, you would have a negative y and a negative x. So what happens is the tangent goes back to positive because two negatives divide to make a positive. And then if you go to this quadrant, you would have y is negative, x is positive, so you'd have a negative like that. Now that's stuff that you see all the time in trig, so you want to have a strategy to quickly figure this out. This is the way I do it. The sine is y over r, so the sine's positive there, negative there. The cosine's x over r. Cosine is positive there, negative there. Does that make sense? Okay, if you get that in your mind, to me that's the easiest way to categorize that. And then the tangent ends up being positive wherever the signs are the same. So there or there. Okay, and then it ends up being negative in opposite quadrants like that. All right, so that's how you put that together, and you want to have a strategy for quickly figuring that out when it shows up. Okay, so what I'm going to do on this is I'll show you kind of the way, a quick way to figure this out is to draw a diagram. What we're doing on this is I've given you two pieces of information. I've given you the cosecant is positive and the cotangent's positive. We've got to figure out where those two conditions come together in the quadrants. So this is the way I teach students to do this, just kind of by doing check marks. You can also reason this out in your head with practice. Okay, the cosecant is the reciprocal of what trig function? The sine, right? Okay, so we can really just think of this as where is the sine positive? Okay, where's the sine positive? Sine's y over r, so therefore where is it positive? Up there. Okay, so put a check mark there and put a check mark there. So that's where that is. Okay, the cotangent's the reciprocal of the tangent. So like we did on the last page, the tangent's positive. Where was the tangent positive on the last page?
1 and 3.
1 and 3. Okay, so let's put a check mark here and there. So that means the two check marks come together there. So we have to be in quadrant 1. Okay, you got the two conditions like that, and they always overlap in only one quadrant. Does that make sense what I did? Just kind of look at where each thing is true, and then where they overlap is going to be where you are. Okay? All right? This next one would go like this. Okay? Again, cosecant is positive. Okay? That's the same thing as the sine. So if you think about sine positive, that is true up there. Okay? So that's where that goes. Is this the same problem?
Yes.
I thought it was looking kind of familiar. Okay, well anyway, the cotangent is going to be positive, we said here and there. So we're there. Okay? All right, I don't know why I did that, but anyway, we're back in quadrant 1 again, okay? All right, let's do these together. I guess these are slightly different then, okay? And see if we understand this okay. All right, so again, what you want to do is the secant is negative. The secant is the reciprocal of the cosine, okay? So the cosine's x over r, right? So where would the cosine be negative if it's x over r? This way, yes, exactly. So what you do is the cosine is negative here and there, okay, like that, to the left, all right? The cotangent negative, okay? The cotangent negative ended up being in, if you look at the diagram on the last page, was here and there. Okay, so it goes like that. So that means what quadrant are you in? 2. Okay, that's how you figure it out. Some of you look puzzled. Are we okay? The way you'll get this down better once you get that diagram put together better on the previous page. That's what happens, okay? Okay, next one. Okay, secant negative. Secant negative would be in these two places. So the secant's negative in those two quadrants. where is the cosecant negative? The cosecant is r over y, so where is y negative? Down, right, exactly, okay? So that means the cosecant would be negative there and there. So that means that you are in quadrant 3. Okay, that's a quick way to figure that out. It's just by doing that diagram. You're always going to have, each statement's going to be true in 2 quadrants, and they're always going to overlap in 1. That's the way that goes together. Okay? Now, part of the reason we do this, and this next thing that we're doing, is it's an activity that trains you to know your definitions of the trig functions and think about the signs. So that's the idea. So this part right here, there's a lot of thought to this. So the first thing that you want to do is I've given you the secant theta is 9 over 4. So I've given you actually 2 of the 3 variables x, y, and r. Okay, the secant's definition is r over x. Okay, I've also given you that you're in quadrant 4. So if you're in quadrant 4, then you know x is positive, y is negative, and we know that r is always positive. Okay? So that means that r is positive 9, and it's positive because r is always positive. X is going to be positive 4 because we're in quadrant 4. Okay? How do you find y? Pythagorean Theorem, x squared plus y squared equals r squared. So we're going to go ahead and do that. So we have x squared plus y squared equals r squared. And you'll do this all the time. So this is going to be 4 squared, x is 4, y we don't know, r is 9. So you want to complete the Pythagorean Theorem to find that. So that will be 16 plus y squared equals 81. Subtract 16 from both sides. That'll give y squared is equal to, I think, 65. Okay. Then you do square root of both sides. And remember, when you do that, you really have a plus or minus square root of 65. Which is it? Plus. Are you sure? We're in quadrant 4. Yeah, it's minus, okay? So you got to do minus square root of 65. Okay, because see, you're given that you're in quadrant 4. So you have to reason out that that's negative. Trig is very picky about signs. If you've taken trig before, you know that. So you got to be really solid that you know the signs for each thing. Okay, now from here, it's just a matter of putting it all together. The sign's y over r, so that means you would have negative root 65 over 9. That would be the answer there. The cosine is x over r, so that would just be 4 over 9. That would be your answer there. Okay, and then the tangent is y over x, so that would be negative square root of 65 over 4 like that. Okay, so that's how that goes. Now you just do the reciprocals. Okay, the cosecant is negative 9 over root 65, but you need to go ahead and rationalize the denominator, which you can do in your head. So I'm going to rationalize the denominator to get negative 9 root 65 over 65. Okay, so that takes care of that. The secant is the reciprocal of the cosine, so that's 9 over 4. The cotangent's reciprocal of tangent, so that's negative 4 over root 65. Then if I rationalize the denominator, that's going to give negative 4 root 65 over 65. Okay, like that. Okay, does that make sense what it did? Okay, does everybody understand the signs, how I figured that out? Okay, quadrant 4, the key is you're in quadrant 4, so that's why you know that x is positive and y is negative. That's the idea. Everything up from there is you got to know the definition of the secant to figure out the 2 variables that you were given. Okay? The biggest part of that problem for most students is the signs, messing up the signs. So that's what you got to pay the most attention to. Okay, next problem, let's see. This time I've given the cotangent of theta is equal to negative 7/4, and I put that negative in the front of the fraction bar on purpose because you don't know which it is. It's either 7 or 4. So what you want to do is you want to look at these 2 statements and you want to figure out what quadrant you're in. Okay, this is what I was showing you a few minutes ago. So the cotangent is negative in this problem. The cotangent is negative in 2 places. It's going to be negative there and there. Okay, that's where you find the cotangent's negative. Then we have the cosine is negative. That's what that statement is saying. The cosine is negative in this quadrant and that quadrant. So you're in quadrant 2, right? So you have to figure out that we're in quadrant 2. All right? So if you're in quadrant 2, x is going to be negative, y is going to be positive. So you'll have a negative x, positive y, and r is always positive. Okay? Is everybody okay there? If you're not, it's because you might not be real clear on enough clarity on the definitions of the trig functions to process that okay. Right? Now, what the next thing we want to do is the cotangent is x over y. You got to know that definition. So therefore, x is going to be negative 7, and y is going to be positive 4. Okay, like that. So you have to know the definition to figure out x and y. When you find out r, you're going to do the Pythagorean Theorem again. So you're going to have r squared is equal to negative 7 squared plus 4 squared. So that's r squared equals 49 plus 16. And let's see, what's that? 65. So what you'd end up having on that when you do the square root of both sides, you'd end up having r is equal to positive square root of 65. Okay, is there any question about the sign, or how I'm figuring the sign out, or how I know that I was given x and y, or any of that? Okay, got to know those definitions, that's key, right? And then the next thing is we're ready to put it together. The sine's y over r, so y is 4, r is square root of 65, okay, and you'd rationalize. And then the cosecant, you can go ahead and do the reciprocal, would be root 65 over 4. Okay, the cosine is x over r, so that would be negative 7 over square root of 65. Then you'd rationalize. Secant's the reciprocal of the cosine, so that would give this. Okay, then we do the tangent and cotangent. The tangent's y over x, so that would be 4 over negative 7. And then the cotangent would be the reciprocal of that, so that's negative 7 over 4. Okay? All right, so that's how that goes. And if you rationalize, I'm not going to show the step. The rationalizing on this, you would get negative root 65 over 65 there. And for the sine, you would get 4 root 65 over 65. You can do that in your head. I don't care. All right, so that's how that goes. All right? Is everybody okay? Okay? All right? Okay? You probably won't have too much trouble with that, but just try to get confident on what the signs are. I usually just teach this diagram and put check marks. That seems to be what works best for most people. Just do it that way. Ultimately, you can do that in your head. Okay, so you can also do this. If you don't like reasoning out, what I try to get students to do is this. Sine is positive here, negative there. Cosine's positive there, negative there. Okay? Tangent is positive in opposite quadrants, negative in opposite quadrants. Well, here's a couple of ways. I've been shown several ways throughout my career. There's all students take calculus. I think in there. Does it have that in there? Well, I thought it did. Yeah, you can do all students. Write it down if you want to. That's all students take calculus. So this is just kind of a way somebody came up with. It's kind of a mnemonic device to help students remember this. So this just means if you're in quadrant 1, everything's positive. All 6 trig functions are positive. If you go to this quadrant, the student stands for sine. So the sine is going to be positive, and the cosecant is positive because it's reciprocal. Everything else is negative. The take stands for tangent. So the tangent will be positive in this quadrant along with the cotangent. Everything else is negative. Quadrant 4, that's calculus, so that stands for cosine. Right, so you can do that. Some of you have probably learned that before. How about all science teachers crazy? Okay, you can do that. Okay, another one that students told me was this. I got a kick out of this one. Was this. I got this one several semesters ago. How did that go? All strippers take cash. Okay, someone told me that one time. Okay, so whatever works. Okay, you just find something. There's several of those that I've seen around. So you can use that as a way to quickly memorize that if you need to. Okay, I prefer that you just sort of reason it out on the spot anytime you need to. Okay, okay. Now we want to next talk about reference angles, and that's kind of the last major topic that we have in here. So reference angles in trig just means we usually use like theta prime. That just means it's the reference angle to the angle that I'm giving you. And that's going to always be the angle that's between the x-axis and the terminal side of the angle. So this diagram, I just cut and pasted this diagram because I think this shows this well. So if you're in quadrant 1, like a 60-degree angle, the reference angle is between the x-axis and the terminal side. So that would be your reference angle right there. Anytime you're in quadrant 1, that angle is the same as the reference angle. If you go to quadrant 2, like 120 degrees is a quadrant 2 angle, your terminal side's in quadrant 2, so what you do is you go straight down to the x-axis and measure the angle from there to there, so that would be 60 degrees, wouldn't it? Because that's 120, 60 more takes you halfway around the circle. Now you might want to write this formula down if you need to, but you don't have to memorize it because you figure it out as you go. The way you would find this is theta prime would be 180 minus 120. So if you're finding a reference angle in quadrant 2, then you're just taking that angle and subtracting from 180 to get that leftover reference angle. Okay, if you're in quadrant 3, again, what you'd be looking at is your terminal sides in quadrant 3. Your reference angle, you always go to the x-axis. Don't ever go to the y-axis. So you're looking at this angle here, okay? So that would again be 60 degrees in this case. And the way that you would crunch this out this time is you would take the angle I gave you minus 180. So that's how you find it if it's in quadrant 3. Okay, if you're in quadrant 4, again, you go to the x-axis, straight up to the x-axis. So the way you would calculate this is you would go 360 minus the angle that I gave you to get the leftover reference angle. Okay, so a couple of observations on this. Make sure that you're real clear that a reference angle is always measuring the x-axis and the terminal side. Okay, it's always going straight up or straight down to the x-axis. That's what you're looking at. A couple other observations. The measure of a reference angle is always going to be between, now I'm going to have you just write an interval on there. It's always going to be between 0 degrees and 90 degrees, not included. Okay, so we call that an acute angle. So a lot of times I'll see students give me reference angles that are outside of that range, and it can't be that way. It's always an acute angle. It's always between the x-axis and the terminal side. Okay, and to make a reference angle, always connect the terminal side to the x-axis. Okay, so they want to make sure that you're clear on this, and I'll show you kind of what we do with this in the next thing here. Okay, so let's do some reference angles, and we're going to figure out what theta prime is in each one of these things. Okay, and you just want to sort of reason it out on the spot. So if you have a 55-degree angle, you're going to be in quadrant 1. Okay, so what's the reference angle? 55 also, because you go straight down to the x-axis, so that's still 55 degrees. That's what that diagram says. You're your own reference angle. Okay, you go to the next one, you've got 102 degrees. So if you're in 102, you would be in quadrant 2. So your terminal side would be like that. What you do is you draw down to the x-axis, and then you need to figure out this angle right there. So what are you going to do to figure out that angle? What math problem?
180 minus 102.
Thank you, very good. Okay, so we do 180 minus the 102, and that'll give you the theta prime on that, which is what? 7, what is that?
78.
I need a vacation.
We're about to have one.
Okay, so we got that, all right? Everybody good there? Okay,
No.
78.
78.
70.
I just caught that. All right, 78 degrees is that reference angle like that, all right? Okay, and then if we go to the next ones on this, now you're in radians, so on this one, you don't have to, but it's a good idea to just change this to degrees. So we'd have 5 times 180 over 4, 180 over 4 is 45. So if you work that out, you're at 225 degrees, okay? So if you're going to find the reference angle on this, now what you are is you're in quadrant 3. So your angle goes like that, okay? And your reference angle, you're always drawing to which axis? x-axis. Okay, so you need to find that acute angle right there. How do you find it? 225 minus 180. Okay, don't do 270 because that would be looking at the y-axis angle. Okay, so it goes like that. So that means that reference angle is going to be 45 degrees. Like that, okay? Draw a diagram if you need to. Okay, the next one, this is more than 180, so what I would do is subtract 360 from that. So that would be 73 degrees, would be the coterminal angle on that. So actually, if you drew out an angle that's 433 degrees, it would be one lap, and then it would be 73 degrees more. Okay, the reference angle, you go to the x-axis, and you give this acute angle right here, so what would it be? 73. Okay, if you're in quadrant 1, then it's a quadrant 1 angle. So that would mean the reference angle on this then is going to end up being 73 degrees. Okay, like that. Okay, that's the idea. Okay, next one, I'd probably do the same thing. I'd probably just change this to degrees to get a better understanding of where we are. Okay, on this, I'll just do this on the calculator. So if I take 180 times 100, no, what am I doing? 11. Okay, so if I take like 11 times 180 and then divide that by 12, that'll give me a negative angle. So we just need to reason out what that is. So that looks like negative 165 degrees. Okay. Draw a picture on this. That would be clockwise. So you would be in quadrant 3. All right. So that's going to be that angle. It goes straight up to the x-axis. Most of the time you can do this in your head. What is that acute reference angle? 15 degrees. Thank you. Okay. 15 degrees. Okay. So that would be 15 degrees there would be your reference angle on that then. All right. Okay, everybody okay with what I'm talking about with reference angle? Okay, remember it's always between the x-axis and wherever that angle is that I gave you, and you can usually just reason that out. Okay, now these problems at the end of this you can do on the unit circle. So when you're doing your homework, I mean you can do this with the unit circle if you want to, because it's probably easier to learn to do it that way. But just to show you this, if you change this to degrees, which is what I'm going to choose to do, you'd have 4 times 180 over 3. So 180 over 3 is going to be 60, so that's 240 degrees. So we'd really be doing the sine of 240 degrees. Now you could obviously look that up on the unit circle and be done like in 2 seconds. But to show you how the reference angle works on this, if you graphed out that angle, you would end up being somewhere in quadrant 3. Okay, if you do the reference angle, if that's 240 there, then what is this reference angle going to be? 60 degrees, right. Okay, so this is going to be 180. It's the difference between 240 and 180, so that's going to be 60 degrees. Okay, so if you use a reference angle to find a trig function, you go to a triangle. So what you would do here is you're making a 30-60 right triangle out of that then, okay? And then what would happen is this would be the x value, this would be the y value, that would be r. So you got to know the 1, 2, square root of 3 thing that comes from that special triangle we looked at tonight. So basically what goes opposite 30 out of these 3 sides? 30 is the smallest angle, so what's the smallest side? The 1. Okay, so that would be negative 1. All right. Where does the 2 go? That's the biggest, so where does it go? R is the biggest, so that's 2. And then y would be, on this, would be negative square root of 3. Now, it's negative because of the quadrant you're in. You're going left and down. That's why x and y are both negative. Okay? So then what you would end up having on this problem is once you've got your reference angle, then that's going to be y over r. Sine is y over r. So y is going to be negative root 3, and then r is going to be 2. Okay? So that would give negative square root of 3 over 2. And guess what? If you looked at the unit circle, you'd find that anyway. Look that up as the y value. That would be the right one. This is worth showing because in higher math, sometimes students forget all about the unit circle. So having a strategy to figure it out is kind of beneficial. Okay? All right. Let's do just maybe, since you're doing this on the unit circle, I don't want to do all these. It's just want to give you the idea. Let's forget about 28 and 27. Let's just do one more like this. So if you do negative 5 times 180 over 6, okay, that's going to give reduced to 30. So you're really doing the tangent of negative 150 degrees, okay, like this, okay? All right, so if we sketch this out, we would have a negative angle, so we would terminate in quadrant 3, like that. Okay, you would draw straight up to the x-axis. You're going to get what you call a reference triangle. So what will happen is, this is 150, this is 180, so that reference angle has to be 30, doesn't it? So it's a lot like the last problem, except the reference angle is different. So you have a 30-60 right triangle, and then you need to be able to figure out what x, what y, and what r is. Okay, so same thing, you would have a negative x, a negative y, and a positive r. So this time it goes like this. Opposite 30 is 1, opposite 60 is square root of 3, and then r is going to be positive 2. Okay, you got to learn to match those things up. The 1 matches 30, the root 3 matches 60, and the 2 matches 90. Okay? All right, then what you would do from here is, when you work this problem out, the tangent is just y over x. So y would be negative 1, x would be negative root 3. So what that would end up giving you is a positive value. You're in quadrant 3, the tangent's positive in that quadrant, then you just rationalize the denominator, okay? So I'm going to rationalize that. That would give me square root of 3 over 3 like that, okay? Now I suspect that most of you aren't going to do it this way. You're going to do the unit circle. The unit circle speeds this process up. Actually, when I was a trig student, nobody even talked about the unit circle. This is the way we did this, is like this. Okay, somebody just figured out that if you teach students the unit circle, it'll speed the process up. Okay, so when you're doing your homework on this, it's up to you which way you do that.